Okay, now we're going to take a look at example 4 in Appendix B5, and we're given a rational equation to solve. And one of the nice things about working with the equations is we are able to clear out the denominators if we choose to. And actually, since we have variables in the denominator, we have to go ahead and clear them out. So clearing out the denominators kind of works the same way as putting everybody over a common denominator. You have to go ahead and find out what that is. So we're going to take our three denominators here. We're going to factor each of them. And x minus 3, x plus 3, those are already in factored form. And our x squared minus 9 breaks out into the product of x minus 3 times x plus 3. And our least common denominator, when we've got everybody factored, is going to be made up of everything that appears here the most times it ever appears. So we've got an x minus 3 appearing once, not at all once, so it appears once down here. And the x plus 3 appears not there, appears there once, appears there once, so it has to appear in the least common denominator. So now the next thing we're going to do is we're going to multiply both sides by x plus 3, x minus 3. And one of the things that you're going to have to keep in mind is you have to do that to the entire side, the entire left side, the entire right side. And then it's red lettering for a reason. On the left side here, you have to distribute before you start canceling. So I have it rewritten here, distributed, and now you can go through multiplying. Again, the whole reason we chose the least common denominator is that we'd get rid of all the denominators, that we'd obliterate our fractions. So on our first term here, the x minus 3's are going to cancel out, leaving us the 2x times the x plus 3. In our second term here, both the x plus 3 and the x minus 3 cancel each other out, so we're just left with the numerator there, 6 minus 2x. And on the right side of the equation, the x plus 3's cancel out, and we're just left with x times x minus 3. So now we're going to distribute to get rid of our parentheses, which leads us down to right here. We're going to go ahead and collect like terms, clean that up a little bit more. And at this point, we take a look at the equation to determine how we're going to solve it from there. And since it's a quadratic equation, we want to get one side to 0. So we're going to get the right side to 0 by subtracting the x squared and adding a 3x to each side. And in doing that, we get x squared plus 7x plus 6 equals 0. And at that point, if we think it factors, go ahead and factor it. Otherwise, just use the quadratic formula. But I think that it factors, so I go ahead, take my guesses of x plus 1, x plus 6. I needed two numbers that multiplied to 6, added up to 7. That's the 1 and the 6. So I guessed, and I checked, and it's right, so I came back, wrote it in factored form, could set each factor equal to 0 and solve. So when we solve, we get x equals negative 1 and x equals negative 6, but with rational equations, you're not done just because you're at the x equals point. What you have to make sure about both of these numbers is they're not going to make any of your original denominators equal to 0. So if x equals negative 1 would make a denominator equal to 0, we'd have to throw it out. Same thing with x equals negative 6. But with our denominators, the only things that's going to make those equal to 0 is a 3 or negative 3, and neither one of those came up as our solution, so we're fine with x equals negative 1 and x equals negative 6. Thanks.